we're going to continue with the second block, which is Tidyverse, the introduction of Tidyverse. And then we will continue that second block with dplyr, when we get a little bit deeper on it. So I'm starting with the PowerPoint. We go back to where we left. Missing data. So as I mentioned last time, missing data is recorded in R as NA. Okay, that indicates as it's missing data. And some functions can deal with it, and even if in your data set you have missing data and you ask R to do something, for example, a linear regression model, it's going to do it, no problem. But there are some other functions, for example, arithmetic functions like min, sum, that they cannot deal with missing values. So if you want to do the sum of a column, a numerical column that has missing values, you need to say sum and then ignore the NA. And we'll see how sorry. Yeah. Sum is the same pronunciation, or?
Close.
Close, okay.
Pretty much.
And then there are a lot of other different things that you can do in R, and you're gonna get R is gonna return NAs, and we're gonna see some examples of that. There are other nullable values that are null, NaN, so not a number, or infinite or minus infinite, for example, if you're trying to divide something by 0, things like that. So we're gonna go to chunk 4 in our data set. And this one's mine. I'm opening the no solution one. I'll get the other one also open. And if you remember, we can go here. We go to chunk 4, and it will jump there.
And just 3 dashes make a chunk.
So you need to do pound sign just to make it a comment, and then 4 of these.
4. Okay.
Yeah. And you will see, you can see here there's nothing in there. So if I do 1, 2, 3, 4, you have it there. Okay? If I have 3, it disappears. If I do 4, it appears again. Okay? And then you have it back there. So here we're going to create a vector. By the way, you need to go open R full as well, and go to chunk 4. Okay? And run everything that is above that. Okay? Highlight everything and run it.
Everything above chunk
4? Yes, everything above chunk 4 in the R document that is called basics R full.
So except for chunk 4?
Except from chunk 4, sorry. Everything above. Yeah, I think here I ran it. Thank you. So everything before. And this is because we ran some things last time with family. And if we don't run this, when I send you to do the exercises, you won't have all the vectors that we created last time because we didn't save it. Okay? So we have it in the script, and I made you run it. Now you're going to find, because you ran my version, you're going to find the family names that I decided. And I gave them age and all those things. Okay? So if we start with chunk 4, we have heights. What am I doing here? If I run this, what is going to happen? I get a new vector. It's a new vector. It's an object that it's a vector. It's a numeric vector that has all these different variables, elements inside. Okay. So if I run this one here, this is the structure. Okay. So it's a numerical vector that goes from 1 to 5. This is a little bit a reminder from last time. And these are the values that are inside. If I do summary, I get the numerical summary because this is a numerical vector. So what happens if I run min heights? It's giving me an A. So why? Yeah, because I have an A here, and this is one of those functions that cannot deal with NAs. Okay? The same happens with max. Okay? So in order for R to be able to deal with those, you need to say remove NA true. Remove the NAs of that vector so you can carry on with the calculation of the mean. Okay, so if I do this one, if I run it, it's going to say 4 is the mean. Okay, if I run this one, 6 is the max. As you can see, this one here, when we run summary, that one didn't give us any problem. So summary can deal with NAs. Actually, it recognizes it. And it says you have one NA there. It gave me the max without the NAs, and it gave me the mean without the NAs. So there are some functions that can work with it, some that cannot. So if you ever run something and you get an NA, you can do either question mark and whichever the function is, or just try this little attribute here. This is an attribute of the function mean. So just try that and see if that solves your problem. You can always go to Google. So to see if we have any missing values, we say, is there any missing values? Is .na, and we run it. And it says, this one, the first element is not a missing value, the second element is not, the third element is not, the fourth one is. But you can imagine if you have a long vector or something like that, it's a pain to have to look at it like that. So you can do summary of that same function. So it will tell you there are 4 that are not NA, and there is one that, yes, it is an NA. Okay? So this is summary of this line that we had above. If we want to identify the location, okay, like which location inside that vector, the first element, second, or fourth, which one is the one that it's an NA, a missing value, we ask which. Which one is an NA in the vector heights? Okay, so if I run this one, it says the element number 4 is an NA. This is another way to, very similar to summary, that you can just sum the number of NAs, or sum those that return true if this is an NA. So we have one NA. I never use this one, I usually use this one here. But again, there are 20,000 different ways of doing the same thing. If we want to extract those elements which are not missing values, okay, I want to keep everything except those that are missing values. You use this operator here. This exclamation point means no. So which one is not a missing value in the vector heights? So if I run it, the same. This one is not, this one is not, this one is not, this one is a missing value. Okay? If we want to extract them directly in our data set, we're going to use the indexing single brackets that we were talking about the other day. Okay? So what we are doing here is we are taking this same vector, the true, 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 false, true, and we are putting it inside the square brackets to try to find those locations in the vector heights. So if I run this, what do you think you're going to find? What is R going to return?
The values without NA.
Good. The values, the real values, instead of just true, 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 false, or the index, the real values of heights without the NA. Okay? So if you remember here, I'm going to run in the console, in this area, the real vector. So these were the elements. So what we did here is give me all the elements of the vector height except those that are missing values. Okay? This might be interesting for something you want to do. It might not. But again, this is data manipulation, and it's very important that you know how to do this so you can do more advanced stuff. So different ways of doing a very similar thing. We can also extract those elements which are complete cases, where a case is a row. And complete cases means that doesn't have missing values. So it's exactly the same thing as before. This is a different function, complete dot cases. So give me, return the complete cases of heights. And this is again a logical vector, true, 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 false, true. We can do the same thing as we did before. If we want the real values of the vector height, we open brackets and put inside those brackets the function that we just called. Okay? and this is doing exactly the same thing as not SNA. Any questions? So here, thinking the other way around, if we want all the NAs, we say, give me everything that is not a complete case. So give me everything that has missing values. Okay? So again, this is a logical vector. If we want the real values of height, we just put it inside the square brackets. Wait, this is NA. NA. We have one NA. I saw this here like, what did I do wrong? But no, this is returning the one that is not a complete case. So if I run heights again, it's returning this one, which is the one that is true. Okay? So there is one exercise for you to practice here. So go for it, and remember, green sticker, you're done. Red one, you're having problems. If you don't have anything, you're still working on it. Okay, so I'm gonna go with the solution. You can keep trying after seeing the solution, but you can still keep trying later if you want. So I'm asking to create another column for family data frame called profession, where you give a profession to everyone except the dog. So I want you to give the dog an A, because we have a missing value there. And I want you to assign a new column. So how did we do that? So we have the data frame, which is family data frame. And then to create a new column, remember the $sign is the one that is going to call a column. And we write down the one that we want. So right now this one here is empty. If I just run it like that, it's null. There's nothing there. Okay? So I need to assign some values, these values here, to that object, which happens to be a column in a data frame. Okay, so the way we assign it is with that sign, and we say, give me a concatenation of researcher, ID, student, and NA. This one's going to be the mom, the dad, the daughter, and the dog. So if I run this one here, okay, perfect, I don't see anything. If I want to see what happened, I can type down here in the console, family data frame, and have a look at it. Perfect. So before we did not have that column here, we just created it. Okay, then I say, give me all the cases in family data frame that don't have NAs. So how do we do it? We take the name of our data frame, we open single square brackets, okay, and now cases, remember cases are rows, so I'm gonna put these complete cases before a comma, because in this case data frame, family data frame is a data frame. It's not a vector. With heights we had a vector, only one dimension. Data frame has 2 dimensions. Whatever you put before the comma are the rows, the cases. Everything that comes after that are the columns. So if we don't put anything after the comma, it's going to give me all the columns. Okay? So if I run this, I get all the rows and all the columns that do not have missing values. So this output here does not have the last value, because the last value is not a complete case, it's not a complete row, because it has a missing value. Okay? Okay, so here is for you to just play with it, run it, see what's happening. For example, if I say SNA family data frame, it gives me the whole data frame, and it tells me which ones have missing values. But again, imagine you have a big table. This is horrible. So maybe you just want to focus on the column name. Maybe you just want to do summary. So I'm going to do this one here. Just copying it. I'm going to say summary of that one. I plug it inside and I run it. So there are 4 false. So there is no missing value in the column name of the family data frame. Okay? This one the same with profession. We know we have one in profession. Call sum is to compute the sum of the columns, as you can see here, and we have 1 missing value in profession and 0 in the other ones. Okay? Another example is this one here. So we are creating a new vector. So how do you think this vector is going to look like?
Missing values for 5 and 8 would be?
5 and 8, yeah, perfect, are going to have missing values. So this vector x is going to be 1, 2, 3, 4, NA, 6, 7, NA. Okay? So we are creating a new vector, and there it is. Okay, so perfect. So we're asking, does it have NAs? Yes, it does, but this is very, I don't like it. I don't see well there what's happening. So which ones are the ones that are NAs? And as Kyle said, the 5th and the 8th elements, those are the positions. So remember, which is giving you the position, the index, the place where you have those missing values inside that vector that we have. Okay? If we run the mean of x, it does not work. Why? Because we have NAs. Perfect. So we just need to remove the NAs, and it's going to give us the mean. If we extract the positions 5 and 8, okay, we can do that with this x square bracket is NA that. We're going to get the real values of the NAs in the vector x. Okay? Now, I want to change these values. I'm going to do some imputation of the missing values. I want to have the mean of x inside or substituting those missing values. Okay, so we just run this one here, and it's telling me the positions that are NA. So what I want to do, I want you to assign the mean of x to those positions. Okay, so if I run this one here, this line, this one, what I'm doing, I'm imputing the missing values with the mean of that vector. Okay, to see x now, x has changed. And you can see we had here and here we had NAs, and now we have the mean value of the vector x. Is that clear? So now R generated a lot of decimal points. I don't like them. Too many. It confuses me. So I want them to round x with only 1 decimal point. So if I run this line, it gives me what I want. Okay, perfect. But what happens if I run x again? R is giving me again all those values. Why? I just called this one, and it gave me what I wanted, only 1 decimal point. So why now, when I run x, it goes back to all those? I didn't override it, exactly. So I need to x is still this x. So if I want x to become this one here, what I need to do, it's assign that value to x. So I need to override x. If I run this one, and then I run x here in the console, you can see that now this is what I wanted. Okay, so sometimes this happens to a lot of people who are starting. You focus on the function you want to run, but you forget to assign it to the object you are working with. And again, sometimes you want to leave x with the same value, but sometimes you prefer to do x2 or x round. Okay, so you decide if you want to give it the same name or not. That's up to you. Good, so some people, let me go back here. Some people work with NAs, and they go them with 99 or 999, and sometimes you get a data set that has a lot of 99, so R is going to think it's a number. R doesn't know that 99 is a missing value. So that's one of the first things when you get a data set, you need to explore it. You will realize you have missing values, or you will realize when you do a summary, suddenly you see like a lot of 99s or something like that, and then you will realize, okay, maybe this person who gave me the data set has been writing 99 for missing values, or whatever else they have been writing. So we have another example here. In this case, instead of a vector, we're going to work with a data frame. Okay, so we're creating a data frame with 2 columns. Column number 1 is going to have these values, number 1, 2, 3, and 99. column number 2 is going to have these values, 2.5, 4.2, 99, 3.2. So if I run it and I have a look at it, this is what we have. Okay, we just created a data frame. Great. It has a couple of 99s, which are going to be the missing values. We want R to recognize those as missing values. So we are going to use subsetting again, indexing. We take our data frame, we open square brackets, and we say, okay, take those places where data frame equals to 99. Okay, and you need to do the equal sign twice. If you only do it once, R thinks that the assigned symbol here is the same as 1 equal. So if, for example, I say, look at the console here, x equals 1 to 7, and I run it, x is 1 to 7. If I do x assign 1 to 7, x is 1 to 7. So the equal sign in R is the same as this. I prefer to use the assign function because, not function, symbol, because this equal can be actually something else we're going to be using in some functions. So it could be confusing. So every time I'm assigning a value to an object, I want you guys to use this one. I mean, you can do whatever you want, but that's what I do. So when you're asking something is equal to this, you put 2 equal signs. You are asking, this is what I want. So if I run this, what do you think we are gonna get? What is R going to return? We are taking the data frame.
Yeah, the data frame with the NAs instead of.
Yeah, the data frame where, so it's gonna return the values of the data frame where it returns where the values are 99. So as you said, these are the missing values, but in this case the missing value is 99. So we want R to know that those are missing values. So I'm going to assign NA to those locations where the data frame equals 99. Okay? So if I run this, let me run data frame again. I'm clicking enter here just so to make it clear, more clear for you. If I run normal data frame, this is the one we had with the 99. If I run this code here and then I run the data frame again, we now have NAs. We're happy. Now R knows these are NAs and we can continue doing whatever we want. So we have another exercise here, and we're with this, we're almost done with the NA value. So if you can just do it, work a little bit on that. Remember the stickers. Results. You have them in full if you want to look at it at the same time. So create a new column called salary, where you give a salary to everyone except to the dog. Okay, so the same thing as before, very, very similar. Okay, now we can look at our data frame and see if it worked. Perfect. This is a little bit different, but it's still an NA. You'll see why. Well, you'll see why throughout this time. So now recode the salary. So we are doing the imputation with the mean. Okay. So we take that column. We open because we want to impute that one in there. Wait, I didn't run the imputation. No, okay, perfect. He doesn't have a job. We didn't impute that. So we have, we want to impute the one in the salary. So we call for column salary. We open the square brackets. Okay, and we say choose the ones that are NAs within that column. So if we just run this one without assigning anything to it, we are going to get that NA. This NA is this NA here, okay? The one in salary. So now I'm going to assign the mean of the salary of the family to that NA. And remember, because we have a missing value and in that column, in that vector, and mean cannot deal with missing values, we need this one here, okay? So to the mean, we are gonna take only the 1%. Okay, so we multiply whichever this value is, which is this one here in my case, we are multiplying it by 0.01. So what I'm gonna do with all this line of code is I'm gonna put this value where this SNA was. So if I run it and then I look at data frame again, we can see that we imputed that missing value. Okay, and then if we want to get the incomplete cases with this operator, usually you are flexible to do whatever you want, but now when I'm asking you to use that one, we just run this line of code here. Okay, any problems, questions? Okay, so the last little bit here is just some things to run, some situations where R is going to give you an A or maybe even an error. So var is a function to ask for the variance. So we cannot run the variance of one single number because there's no variation, it's a constant. Just one number, it doesn't vary anything. So it gives you an A. If we try as numeric, it's a function that whatever you give it is going to try to convert it into numbers. So this one here, for example, it looks like a number, but it's with quotes, in between quotes, so we know it's a character, really. R doesn't recognize it as a number yet, but we're going to try to say, okay, recognize all these things as numeric. And I run it, but it's saying, hey, watch out, I ran it, I did it for you, but warning, there are NAs in there. So it gave me an NA here because it doesn't know what to do with this. R doesn't recognize this as a number. For example, if we change that, let's see, if I put a 3 here, a number 3, and I run it, it doesn't give me any problem. It knows, okay, this is not a string, remove the quotes, it is a number, I can recognize it. So as numeric function doesn't have any problem for that. Warnings in R mean that R did something, like it's trying to do whatever you want. It did it, it ran it, but maybe it's not what you want. So pay attention to the warning. Sometimes you don't care. It's like, okay, this warning, I know about it, it doesn't bother me. But sometimes, like for example, here, okay, I have an NA, I can live with it. It's not a problem. But maybe you want to know. Like in this case, you actually wanted a number 3 here, so you can convert all this as numeric. We have this one here. What are we doing here? We are creating a vector. We are not assigning to anything, but we are creating a vector with numbers 1, 2, 3. And we are asking for position 4th of that vector, okay? This is, for example, imagine you can look at the console. If I have X, and X now is 1, 2, 3, and I say, okay, I have X, give me the second position. It gives me number 2, perfect. But if I ask for the 4th position that doesn't exist, it's going to give me an NA. Okay, so same thing here, NA. Okay, so these are different situations where you're going to be encountering NAs. And when you do, you will be wondering, why do I get an NA here? That was happening to me the other day. I was getting NA, and I was getting null. So you need to find out why. And these are some possible explanations of why you are getting NA. This is NA minus 1. For example, go to the console. 8 minus 1 is like a calculator. I get 7, but NA minus 1 doesn't mean anything. It gives you an NA. Now we are creating a data frame, okay, that is called A. And this data frame, sorry, I ran it. It has 3 rows and 2 columns. So what is this command here asking for? It's saying, okay, return, give me the 4th row and all the columns of the data frame A. Okay, so if I run this one, I get an A's because my data frame A does not have a 4th column. A only has 3 rows, 1, 2, 3. Okay, you can do that. You can look at that with dim. We saw this one the other day, dimensions of A. It has 3 rows and 2 columns. So you cannot ask R to return the 4th row because it does not exist. The same thing with column. Column gives you a different error. I don't really know why. it doesn't give you an NA. It's pretty much the same thing, but with column. But it gives you an error. It's like, I cannot even imagine what I'm going to do with that. Okay? So with this, we're finishing the first one. What I'm going to do, I'm not going to save this one because it's in the general one. So I say don't save. If you made comments on your own script and you want to save it, you can say save and it will override. Or you can just, if you want to create another one, you can say save as. You change the name, like whatever, Esther. And then remember the .r. And then you save it. Okay, if you want to keep it. I don't want to keep this one, so I don't save it. I don't want to keep this one, so I don't save it. Now, we're going to start from all over. We're going to start with the new package. What happens with all this environment, all the data frames we created? Okay, if I close R, it's going to ask me if I want to save it or not. Okay, usually I don't save it. And I just, when I start an R session again, like we did this morning, I just run all the code that I ran last time. Because I have the code in my script, I just run it. It takes less than 5 seconds for sure. So yeah, I usually don't run it because I want to be sure that I didn't create like new objects when I was like trying. If today we're playing around, sometimes I open like new scripts just to try different things, and maybe I overwrote something, but I don't want to keep it because I only want to keep the one where I've been really working on. Imagine this is the one I want to keep, and these are the crazy things that I've been trying, and maybe I have overwritten. So if I save it, and then my original data frame, let's say it's overwritten, I'm going to find a lot of problems later on. So I usually don't save it. I just keep the original one and just highlight everything when I restart again, like tomorrow or whatever, run it as we did this morning, and that's it. However, that's up to you. You can do whatever you want. I usually don't save it, don't save the environment. However, when I've been working with models that take hours or days to run, I don't want to have to run that again every time I open R, and I don't want to have to not ever close R because, I mean, maybe I need to close it. Maybe my computer dies, or maybe I want to work remotely with the same file. So that would be a situation where I would save my environment. So when I close RStudio here, I would say save, okay? But usually I don't, and I'm not going to save it now. So you have the documentation for this one, so just remember to copy the folder, this one here, into your own directory, folder, or whatever, so we don't override it. Okay, you get in there and you can open this one. And these are the first 2 chunks, because today we didn't have time to finish it all, and I have more than that, so I just wanted to present the first 2. And I think it's a nice break. It's a nice break point. So I'm going to start with it. In this session, the second one, which is going to be part today, part next time, next Monday, we're going to be learning what a working directory is, and we're going to work with that. We're going to load data from a CSV file into our RStudio to create a data frame. We're going to talk a little bit about packages and libraries, and especially we're going to focus on the Tidyverse. Next time we will see dplyr, which is one of the several packages that Tidyverse has, and we're going to be learning how to use these functions here. And I think once you learn how to use these functions, you're going to want to kill me, because I taught you all these things in basics R. But again, it's important that you learn those basic R stuff, because when you're working with more advanced stuff, they still haven't catch up with dplyr. So there are things that you cannot do with dplyr, and you will need to go back to those crazy brackets and indexing and subsetting. And then finally, we will export our data frame into a CSV file. Okay, so this will be next time. So the working directory is simply where your files live. So all the files that you're going to be using in your R session, and an R session is like I'm opening my RStudio and I'm working on it today. need to be in a place, in a, like a physical space in your computer. So RStudio can call it from your computer to RStudio so it can work with it. So you need to specify this working directory at the beginning of each R session if you want to work with files that you have in your computer. So far we haven't done that because everything that we have been creating it. We have been creating the vectors, we have been creating the data frame, but what if you want to get one of the data frames that you have, like the CMS data frame? So you want to import it into R. So wherever you have your files, that's going to be the working directory. There are different ways of getting it. There are 3 here. I'm sure there are more than that. My way, I think, is the simplest one, and that's the one I'm going to teach you. But if you want to explore the other 2, they are here and also in the code. Okay? So we're going to go for R for the chunk, the first chunk. So I want you to use the no solution file, which is this one here. Remember, get the one that it's in, that you just copy pasted in your folder, so we are not opening the same one. Okay, we start a new R session. Everything's empty here. Everything's clean. This is the beginning of R as always. And some things about R that I wanted to mention, just reminders. Object names must start with a letter, so not a number. And it can contain letters, numbers, underscore, and dots. Okay, but dots I wouldn't recommend it that much, although soon enough you're going to see that underscore, it's tricky as well. If you get a plus here in the console when you're typing your code, R is telling you that it's waiting for something else. Like you didn't finish your whatever you want to do. So let's say I'm creating this vector. I'm in the console now. Okay. So yeah, 1, 2, 4, just that. Okay, we have this one here. Let's say I want to see the summary of that one, but I don't close the parentheses. If I run this, you see this little plus here. Okay, it is telling you I'm missing something and I'm trying to do something else, get out of it, and well, sorry, and I couldn't. Okay, I say get me out of there. So the way to get out of it is, I'm going to go right now, I'm going to click the up arrow, and it's going to show me the different things that I've been inputting. So if I am here, I click enter, I see that plus arrow. There are 2 things you can do. One is like, look at the code, it's like, oh yeah, I forgot my closing the parentheses. So you close the parentheses, everything works fine. Or it could be, and now I'm clicking again the up arrow. If I have this, I have the plus sign. If I don't want to finish that code, maybe you run like a huge chunk and you don't know what R is missing, you just click ESC, ESC. Okay, and you are out of it. Sometimes some people get lost in that and you cannot get out of it. We are going to see numbers, vectors with numbers. Sometimes they are going to be numeric, integer, or double. Just think that they are the same thing. Okay, R is inside R, there are different things, but for us, they are just numbers. Okay, so wherever you see numeric, integer, or double, just think it's just a number. That's fine. Okay, so we're gonna start with chunk 1 here today. Let's see what we have. We have chunk 1, some exercises, and chunk 2. Okay, let's see. I think we can finish this. We are setting our working directory. Okay, so to set your working directory, you're gonna use the function set wd. And you're going to open parentheses. Then you open quote marks, and inside that, this, I'm getting it, I just go to my folder, I look where do I have my files, which are going to be these ones. These are the ones, these CSVs are the ones that we are going to be using, and I just click here. Okay, I copy that, control copy, and I come here, so I write down set working directory, open parentheses, open quotes, and I'm going to paste it in here. Okay? So you see it's still a little bit different to what I had before. That is because this backslash, we need to change them to normal slash. Okay, so I changed that one, this one, this one, and this one. Okay, if you don't, it's not gonna find it. So let's say I have this, I forgot to change this one, and I try to run it. Okay, error. It's a why error in this thing that I just ran. It cannot change the working directory. Why? Because it cannot read it. It doesn't know what this is. So I look at it and I realize that I didn't change that one. Okay, so now if I change that one, I run it. Okay, nothing happened. So how do I know that I'm in my working directory? I run get working directory. I run this one and it says, hey, your working directory is here. All the files that you're going to be asking me to load into R, they need to be inside this folder. If you have another file somewhere else, you need to change the working directory because R is not going to find it. If we want to know which files I have in my working directory, I say list.files. And these are all the files that we have inside that working directory. See?
Where are packages? Where are packages?
Packages are saved in wherever you have R in your computer. So I don't know if I have it in C, in file C, so packages will be there. And then you can go to R, and if you find it and you click on it, you will see the different packages you have. You can see folders within R with the packages. Yeah. So let's say that you only want to list the files that have CSVs because, yeah, you might have plenty of things in that file, but you only care about the CSVs because this is what we usually work with. So you say list files, but give me the pattern, the ones that are CSVs, and you ask for it like this, and it says, okay, I have 3 CSV files in this working directory, and these are the files we're going to be working with today. If I want to move one folder up, which I never do, you can do set working directory and then 2 dots, and it will bring you one folder up from wherever your working directory is right now. So I'm going to the console, and before change it, I say get working directory. Okay, that's the one I told him. If I go one folder up and I check where is my working directory now, you can see that right now is this one here. So it went to the parent folder. I never use it because I want to know where I am. So if I put these 2 dots and I have a lot of code in between, I don't know where it's taking me. So I prefer to see it all here. So if we list files there, now we see that the files we have there are the 2 folders with basics and dplyr. Okay. If I want to list the objects we have created in this session, I created this ASD. Okay, so it says none yet, but actually we're going to find one. Yeah, you just type ls and it tells you all the objects that you have in your environment right now. Okay. So now we're going to learn how to read a CSV file. So we set the working directory. Okay, as we did before, I just copy pasted what I had before. I just want to be sure this is where I am. And I said, I'm going to create an object that is called surveys base, because for this one I'm going to be using base R, which is what you know so far. And I'm going to assign something to it. What I'm going to assign is this CSV file that you should have in your folder. And I say read.csv, open parentheses, quotes, and then the name of the file with the extension. Okay? And I run it. Did it work? Yes, I can see it here in my environment. Are you all there? Were you able to set a working directory that works for you? Because this is individual, so each of you are going to have it different. If you have problems at any time, you show me the red sticker. Okay. So now the first thing we do, we load it, but I want to be sure that everything's loaded well before I start going and do crazy stuff. So there are a lot of different things, and as you can see here, yeah, you have a few of them. I usually use head, summary, structure. If I have plenty of columns, maybe names. So let's go over them. Dim is going to give us the dimensions, the number of rows, and the number of columns. But if you only want the number of rows, you can run nrow, this function, or you can run n column for the number of columns. Okay, we're getting the return value here. Let me know if I'm going fast. Head, we already saw it last time. If I run it just like as it is, the default value is like it's gonna give me the first 6 rows. If I wanna run, let's say, the first 15, if you look at the console, I have head surveys, then I do a comma and I say 15, Control Enter, and it gives me the first 15 columns. Tail gives you the last 6 rows, okay, if you want to start from the bottom. Names gives you the names of the columns. Row names give you the names of the rows, but as we are working in a data frame, like the types of data frames that we have, we don't have row names. So if I run this, it's very annoying because this is what it gives me. Okay, as you can see, R is saying, okay, I reached my maximum. I can only print 1,000, and you have more than 1,000. I'm not printing more. I omitted all these many, luckily. You can always change these options. So here is saying, what is my maximum? My maximum is 1,000. You can always change it. Okay, I usually don't change it. I leave it like that, but you can change it, and you can just Google how to change the maximum, like get option max print. A very valuable one, like really nice one that I always use, you already know this one, structure. It tells me the class of my object. This is a data frame, the number of observations or rows, the number of variables or columns, and then for each of those columns is telling me what type of, what class or type of variable object we have. And then this is what we were looking at the other day as well. Okay, you see this one is a factor, and now it's giving me the first few levels of the factor, and then it's giving me how it is reading it, like 16 is that, like the 16 in alphabetical order. We looked at this last time. If you want to go back to it, let me know. Okay, if we want to see the entire data frame, we can do a couple of things. One is view with capital V, okay, and then a new window will open here, and then we can look at it. I want you to notice this. I said that R doesn't give you empty cells. That's something that SAS does, I think, with character objects. If you have a missing value, I don't like that because I don't like an empty cell. So what is happening here? I'll let you think about it. I have a tip somewhere, just here. Okay, exercise 1. So try to do the exercise 1. It's easy. It's just to remember a little bit how things work. No, it's easy, but that last question is not obvious. So for this data set, we're going to be working with it with dplyr. There is a description of what the variables are in a README document inside the folder dplyr, but it's like I took this from a website like Data Carpentry for biologists. So it's a survey that they did with birds, and these are the variables that they were recording. So yeah, we want to use surveys base. I modified in the folder here, surveys base. Thank you for that, Kaya.
Yeah.
Okay, so we're going with it based on the output. Yeah, I changed it here, and I changed it in some other places here underneath that we had, okay? So we saw it is a data frame just with structure. We see that. This is the number of rows, the number of variables, and how many species we have. So I go to species, and I see factor 40 different levels. So we have 40, okay? There's another one here, species ID, that says 48 levels, but I want to know the species that we have, 40 different levels. Okay, so 40 different species. Now, what about those empty values in sex? Who can, did you find out what happened there?
It has numbers.
Huh?
Looks like it has numbers.
It has number. How did you find that out? Let me know.
Structure.
Structure here. Gender. It has numbers. These numbers. Not really. These numbers are, yeah, the way, yeah, these are the way R is reading each of the levels. Because for you the levels are,
But it has number 3. Right?
it has number 3, exactly. So there is an extra factor. It should have only 2 factors, female and male. So this number 3, you can see the names of the levels here. We have F, M, and this one. This one is nothing. So what happened here is like when they recorded the data, they left it empty. Okay, it's a missing value. But R didn't read it as NA because R read this as a factor. Okay? When it read it as a factor, it thought that these empty things are a factor. And this is one of the problems we have with, I mean, not really a problem, but it's something that you need to remember about read.csv. So in the arguments of this read.csv, these are all the different arguments, okay? Read table, sorry, this one, read.csv. These are all the different arguments that you have. When you see these 3 dots, is that it can take many other arguments, so you can still tell read CSV a lot of things. One of the things you can tell them is like read the empty spaces as NA. Okay, so there are ways to go around it, but this is why. If you see an empty space like that, this is something that you will realize when you are doing your data exploration and you see that there is a factor here. You can always do levels of survey base of the variable species, not sex. Okay, so give me the levels, and I see this one here. So I already see that this level is wrong. This is something wrong happening there. So what can I do here? I can just impute it. I can put it in, I can say this is an NA. I can do several things. This is an example. I'm not going to go into details now. If you really want to know, let me know, and we can do it later on. So there is another exercise here, so I will let you do it. And I think we're going to do this one, the third exercise, and we're going to leave Tidyverse for next time. I want you to work a little bit more instead of just listening, because I want you to become more agile with her. We're going to see the second exercise. So create a new data frame that is called surveys underscore 200, containing only the last data, the last row. Oh, no, sorry, the row 200. So I type the new object, and I'm going to assign it a value, and that value is going to be the row 200 of surveys base. Okay? If I don't say anything here, it's choosing all columns, which is what I want. So if I click it, this is the new object, which is a data frame with only one row. Sorry, that's, yeah, so 200, yeah, which is the same as this, yeah, because this is the value that I assign to the object. Okay, then the second one is I'm asking you to create an object that is called a data frame, that is called surveys last, only with the last row of the survey. Data frame, survey base. And here you can use 2 different ways. You can use en row or tail. So if I use en row, it tells me the number of rows that we have, and I say, okay, so I want the last one. So I just take this value, I paste it here, okay, and I say from surveys base, extract or give me that row and all the columns, okay? I can also just do the same thing from surveys base, open square bracket, and just plug this thing in. This thing is this number. So if we plug this thing in here, in the row section and then comma all columns, it's gonna give me the same thing. Okay, so I click enter here in the console, so you can see that's the number and this is the row that we want, which is the same thing as this one. Another option is using tail. If you remember, tail is giving you the last 6 rows, but I just want the last one, so I can do tail service base comma 1. Okay, now to see if these results here are the same as this one, if my 2 options are the same, I just copy this, paste it there, and I'm gonna ask, so again these 2 equal signs, is what I have in the left side hand the same as what I have in the right one? True for everything. Okay, here we have an A, but no problem. True for everything. Okay, so this is a way that you can have, like, to double check some things. I usually don't use this way, but sometimes it's a good idea. Okay, then use any of those methods to create survey last. So I chose this one and I'm assigning that value to surveys last. Okay, exercise 3, who has done it? Have you finished it? Okay, so I'll give you some minutes to do it, and then we will finish with this and with some things that I want to say. I'm gonna go with the solutions. Okay, so to load the new file, I create the new object. Okay, nodes base, and I'm gonna assign this value, read CSV data. Now I don't need to call the working directory again, because I have this file in the same place as I had the file surveys. Okay, so I don't need to call the working directory anymore. Then these are some functions that I use to explore my data. Okay, you can use as many as you want from the ones we saw. Maybe you can find some new ones. We can see there are 40 observations, 7 variables. Here you have them. Okay, this is the first part, so those are names. These are participant names, a specific unique identifier ID. We have latitude, longitude, premise type, so market, farm, scale, market, industrial, backyard, industrial, and area, north, south. Okay, so my question is, what type of premises do we have? So how do you explore this one here, premise type? Premise type is a factor. Okay, so how would you know which levels do we have? You can look at the structure, okay, but it has 3 levels and it's only telling me 2, so I have a problem. What else can you do?
Structure for the premise type.
For the premise type, okay, so nodes, column, premise type. Still no, it gave me the same thing as before. Summary? Summary of what?
Summary of node space, dollar sign.
Yeah, it tells me I have farms, 38, 1 market, and 1 slaughterhouse. Another idea, yeah, so I had summary here, so that's what you can do. Yeah, summary. Yeah, if you just run summary, it tells you these 3. Okay, but what Moniz said, it's a better idea, because what if I have many more? What if I have like 150? It's not going to show me here. So what Moniz said, this one, summary, node base, column, premise type, that's perfect. Or you can also just call the levels. Which levels do we have? Okay, so this is a data frame that I used for my previous workshop for networks. Okay, and what I was thinking, I wanted to ask you, I was thinking of just using this one, which is not very relevant for you because it's pigs being moved from one farm to another. But what I like is that it is short and you can see what's happening. At the beginning I started working on one with the CMS, and I wanted to use one with HAI, so it will have more relevance to you. But there are several problems. One is too large, which no big problem, we can make it shorter, but it can be a problem if we have the the transfers because we don't want to cut the ones that we have in the node attribute. So making it short, it can be a problem. It can be done, but it can be a bit lengthy to do it. But also another problem is like it will be confidential data. So if some other people are seeing this like in a few months, I don't know, maybe not you, that could be a problem. So I like this database because it's small, it's very manageable, and this is made up data. So that doesn't have any problem. So are you okay with this data to keep working with that one, and then with the nodes farm base for the network and everything? I mean, it's not relevant to you, but at the end the concepts are the same.
Same. Do you have any? Okay.
Yeah, okay. So one of the things that I want you to do, may not for next time, but for the other one, so now start thinking about a data set you have and you want to work on. Because I'm gonna let you some time to work on your own data set, to clean it, to modify it, to change it. Those are the things that we're gonna be doing with dplyr, and we're gonna see it next time. So next time we will still be working with this summary and these nodes data sets. But next time, I think you are gonna be doing everything we learn with dplyr in your own data set. Like that, if you have problems, I can be with you just to play around with something that is more meaningful to you. And I want you to play around with it, because if you just see this, yeah. So yeah, start thinking about which data set you want. We won't use it on Monday, but probably on Wednesday you will be using it. And that's it. You can just close and not save anything. That's what I'm going to do, but you can close and save it if that's what you want. Let me know if you want more time.